Good morning to all of you. I am very happy to introduce myself for a discussion of mathematics plus 1 plus 2 whole syllabus with the orientation for IIT. There was a gap in between. Now we will continue the lessons until it is finished. Now we start with chapter 1. First year, unit 1, permutation, combination and binomial theorem. Now we will be, for the time being, taking the basics and then we will go in details. Permutation means arrangement. For example, if you are given A, B and C, we take 2 at a time. The arrangements are AB, BA, AC, CA, BC and CB. So we observe that there are 6 arrangements. We say 3P2 equals 6. Thus, NPR equals the number of arrangements of n things taking R at a time. 3P2 is simplified as 3 into 2. 4P2 is simplified as 4 into 3. NP2 is n into n minus 1. Now, if there are 2 vacant places, the first place can be filled in 3 ways, the second in 2 ways, so that together they can be filled in 3 into 2, 6 ways. If there are 4 things, the first place can be filled in 4 ways, the second in 3 ways, together 4 into 3, 12. Similarly, if there are n things, the first place can be filled in n ways, the second place in n minus 1, so total is n into n minus 1. Now we consider fundamental principle of counting. In the physics, there are 3 ways from A to B and ways from B to C. Together, from A to C, there are 3 into 2, 6 ways, because you can move 1, then 1, 1, 2, 2, 1, 2, 2, 3, 1, 3, 2. For 3 ways from A to B and for 2 ways from B to C, there are 3 into 2, 6 ways. Now, if there are m ways of doing one thing and n ways of doing a second thing, the 2 things together can be done in m into n ways. This is called the fundamental principle of counting. Now we consider an example. The number of 3-digit numbers using 1, 2, 3, 4 and 5 without repetition. Now unit place, 10th place and 100th place. Now the 100th place can be filled using any of these. So it can be filled in 5 ways. There is no repetition, so the 10th place can be filled only in 4 ways. And the unit place in 3. And by fundamental principle, it is 5 into 4 into 3, 60 is the answer. Now if we consider the number of 3-digit numbers using 0, 1, 2, 3 and 4 without repetition. Now unit place, 10th place, 100th place. 100th place can be filled only in 4 ways. Therefore, 4 comes for the 100th place. In the 1000th place, you can fill 0. Therefore, out of these 5, 1 is taken for the 100th place. There remain 4. So it is 4. And then the unit place is 3. So 4 into 4 into 3, 48 is the answer. Now we consider an example. Number of arrangements of the letters of associations. Now we observe that there are 12 letters altogether, but there is repetition. A is repeated 2 times, S 3 times, O 2 times, I 2 times, and C, T, N 1 each. So the answer is, total is 12, so you put it as 12 factorial divided by, for any repetition, it will be a factorial in the denominator. So 2 factorial, then 3 factorial, 2 factorial, 2 factorial. Now this can be simplified. Now factorial n is simply n into n minus 1, n minus 2 up to 3 to 1. Now for example, this word assist, total is 7 divided by 4s, so 4 factorial. So answer is 7 into 6 into 5 is 210. Now this is important, 0 factorial is 1. Minus 1 factorial is infinity, because you know our problem is to reach 1 from minus 1. So if you move from minus 1, you have to move a lot to come to plus 1. Now if this is 2, this is 3, this is 4. Now 4 factorial means 4 into 3 into 2 into 1. So you need only move backward. So movement is always backward. So from minus 1, you have to move back and come to this 1. So the number is infinitely large. So it is infinity. We consider circular permutation. It is arrangement along a circle. Now number of permutations of n things around a circle. Now we know there is no starting point for the circle. In the case of a straight line, there is a starting point. But in the case of a circle, there is no starting point. We take one thing and fix it. This gives the second place can be filled in n-1 ways, because one thing has been taken for this. So the second place in n-1 ways, the third in n-2 ways, the fourth in n-3 ways, and so on. So finally, the answer is n-1 into n-2 into n-3 into etc. giving factorial n-1. So if n things are there along a circle, the number of arrangements is only factorial n-1. Now we consider combinations. Combination means group. Now consider 3 things, A, B and C. Take 2 things at a time. We have the groups AB, BC and CA. Here 3C2, number of combinations of 3 things taking 2 at a time. The number is 1, 2, 3, so it is 3. So we have 3P2 permutation, 3P2 was 6 and 3C2 is 3. So number of combinations will be less than the number of permutations. Now we observe AB and BA are different arrangements, but they form the same group. Similarly, BC and CB are different arrangements, but they form the same group. CA and AC are different arrangements, but they form the same group. So number of groups will be less than the number of permutations. Now we consider 3C2 is 3C1, because whenever you take 2 elements out of 3, 1 element is left out. 4C3 is 4C1. You take 3 elements and then 1 element remains there. So number will not change, number of groups will not change. 5C2 is 5C3, because when you take 2 elements out of 5, automatically 3 elements are left over. So each time when you take 2 elements, there remain 3 elements in the other group. So number of groups will be same. So in general, NCR is NCN minus R. This result is important. Now let us see the relation between NPR and NCR. NCR groups are there. So number of groups is NCR. And each group contains R things. So that one group containing R things can be arranged in factorial R ways. Hence, NPR is NCR, number of groups, into the number of arrangements. So NCR into factorial R. Now NPR is actually n-1, n-2, up to n-r plus 1. You multiply numerator and denominator by the remaining terms, n-r minus 1, up to 3 to 1. So final result is NPR is factorial n divided by factorial n minus r. NPR is factorial n by factorial n minus r. Make sure that you get this. Now we consider this. NPR is factorial n divided by factorial n minus r. Now factorial n by factorial n minus r is actually NCR into factorial r, because NPR is NCR into factorial r. So NCR, bringing this factorial r down, gives you NCR is factorial n divided by factorial r into factorial n minus r. So this is a fundamental idea. NCR is factorial n divided by factorial r into factorial n minus r. Now NCN is factorial n divided by this factorial n into the difference 0 factorial. But if there are n things, we take n of them together, there is only one group. So NCN is always 1. So 1 equals this n factorials cancels, giving you 1 by 0 factorial, or the idea 0 factorial is 1. Now we move to this. NC1 is factorial n by factorial 1 into factorial n minus 1. So factorial n minus 1 will cancel with the factorial n, giving only n. So finally it is n divided by 1 or n. Similarly, NC2 is n into n minus 1 by 1 into 2. For example, 100C98, 100 factorial by 98 factorial into 100 minus 98, which is 2 factorial. 98 factorial will go with 100 factorial, leaving 199. So 100 into 99 divided by 1 into 2, the answer is 4950. And that is simply 100C2. Now if you consider 79C78, it is simply 79C1, and that is 79. Now we consider the result. NC0 plus NC1 plus NC2 up to NCN is 2 raised to n. In the next session, we will prove this result. For the time being, get the idea. Now for example, 5C0 plus 5C1 plus 5C2 plus 5C3 plus 5C4 plus 5C5 equals 5C0 is 1, then 5C1 is 5 divided by 1, 5C2 is 5 into 4 by 1 into 2, 5C3 is 5 into 4 into 3 by 1 into 2 into 3, plus 5C4 is 5, 4, 3, 2 by 1, 2, 3, 4, plus 5C5 is 5, 4, 3, 2, 1 by 1, 2, 3, 4, 5. 5C5 is simply 1. Now we come to this. 1 plus 5 plus 10 plus 10 plus 5 plus 1. It is 32. It is simply 2 raised to 5. This formula comes there. Now for example, if 7C1 plus 7C2 plus 7C3 plus 7C4 plus 7C5 plus 7C6 is required, we add 7C0 and 7C7 and write it is 2 raised to 7. So the final answer is 2 raised to 7. Take away 7C0 and 7C1, 7C7. So finally it is 2 raised to 7, 128 minus 1 minus 1. It is 126. 7C7 is 7C0 is 1. We consider binomial expansion. A plus b, the whole raised to n, means a plus b into a plus b into a plus b, etc. repeated n times. Now if you take a, you get a raised to n. Now keep one apart, multiply a and take b from the removed one, giving you a raised to n minus 1 into b. Now we see one thing can be removed out of n things in NC1 ways. So you get a term NC1 a raised to n minus 1 into b. So understand a from n minus 1 terms and b from the leftover, be giving you a raised to n minus 1 into b. Now the second can be removed, the third can be removed. So that business can be done in NC1 ways. So one thing out of n can be removed in NC1 ways. Now for a raised to n minus 2 b squared, you take two things at a time. It can be done in NC2 ways. And a from the remaining and b will give you b squared. So finally you get NC2 a raised to n minus 2 b squared. Finally, b up to b n times is b raised to n, and ncn is 1. So you see the coefficients come as nc0 a raised to n plus nc1 a raised to n minus 1 into b plus nc2 a raised to n minus 2 into b squared plus etc. ncn b raised to n. Now if you put a equals 1, b equals 1. 1 plus 1 is 2, 2 raised to n. nc0, this is 1, this is 1, this is 1. So you see nc0 plus nc1 plus etc. up to ncn. So this is the result. Now if you put a equals 1 and b equals minus 1, 1 plus minus 1 is a 0. So 0 raised to n is a 0, giving you nc0. Then this is minus 1, so minus nc1. This is minus 1 the whole square, so it is plus nc2. So you see 0 equals nc0 minus nc1 plus nc2 minus nc3 it goes. Finally you see minus nc1 can come over here, minus nc3 can come over here, giving you a result. nc0 plus nc2 plus nc4 plus etc. is nc1 plus nc3 plus nc5 plus etc. Sum of even terms coefficients equals sum of odd term coefficients. It's an important result. Now we consider nc0 plus nc1 plus nc2 up to ncn is 2 raised to n. Now nc0 plus nc2 plus nc4, that sum of even coefficients, equals nc1 plus nc3 plus nc5 etc. sum of odd coefficients. And suppose this is s, then the whole thing is s plus s, which is 2s. So 2s is 2 raised to n, this is 2s, because if you add these two, you get the whole thing. So 2s is 2 raised to n, you can divide by 2, giving s is 2 raised to n minus 1. So this fellow is 2 raised to n minus 1. The result, nc0 plus nc2 plus nc4 etc. is 2 raised to n minus 1, which is same as nc1 plus nc3 plus nc5 plus etc. So suppose you consider 7c0 plus 7c2 plus 7c4 plus 7c6. It is 2 raised to 7 minus 1, 2 raised to 6, which is 64. Note that 7c8 has no meaning. Given 7 things, you cannot take group of 8. This number, NCR, when you say NCR, this R must always be less than or equal to n. So this is a result. Given n things, you can take only up to n things. You can take 0 things, you can take 1 thing, you can take 2 things, but you cannot go beyond n. So R should be always less than or equal to n. If NC8 equals NC4, find NC2. So our problem is determining n. Now we apply NC8 is actually NCn minus 8. And that NCn minus 8 is NC4. So we see these two fellows are one and the same. So n minus 8 is 4, or n is 8 plus 4 equals 12. If n is 12, you go for the answer. 12 say 2, it is 12 into 11 by 1 into 2. It is 66. Now please go through the fundamentals we have explained. And in the next lesson, we will be dealing with more higher problems. We will continue all these targets of +1 and then +2 and then entrance orientation. So we will continue all these properly. So be assured. Best.